Great day, everyone, and welcome to our another video. So for today's session, we are going to talk about the second lesson for the mathematics in the modern world. And our topic is all about Euler circuits and Hamiltonian circuit. Okay. But before, of course, we will dive into the different important concepts about the topic Euler circuit and Hamiltonian circuit. It's important that we will be guided with our three learning outcomes for today's session. The first learning outcome is analyze a given graph to determine if it has an Euler's or Hamiltonian circuit. The second learning outcome is at the end of the session, you're expected to draw and label graphs showing these circuits correctly. So while the video is on progress, I will advise you to have your your scratch paper there or any notebooks, and then you will try to draw and label the graphs based on the given examples later. And of course, at the end of our session, you're all expected to appreciate the importance of graph circuits in real world network design and optimization. Okay, let us review the concepts first, the fundamentals of graph theory, before we will be talking about the main topic, Euler circuit and Hamiltonian circuit. Okay, so what is a graph? Again, according to the fundamentals of graph theory, graph is defined as a set of vertices where these vertices are the points connected by an edges, refers to the lines, and graphs are used to model networks, roads, connections, and systems. There are different examples or real-life applications of graph. The first is roadmap. The second is social network. The third is computer network and many other real life applications. So remember, a graph theory is composed of a different components, and these are the vertices and the edges. Vertices are the points, or specifically, these are the cities, your destinations, the person, if it is a social network, and the edges are the lines that connected to these vertices. Say, for example, the roads or the line itself. So that is an edges. Let us not forget as well the degree of the vertex. The degree of the vertex is identified by counting the number of edges that is connected to that specific vertex. Okay. Now, let us first define the first important concept, or the first main topic for today is an Euler circuit. But before the Euler circuit, it is important to understand the topic or the concept of Euler path. Euler path is a path that uses every edge of a graph exactly once. Remember that it will start and ends at different vertices. A graph is an Euler path if it has exactly 0 or 2 vertices of odd degree. When we say odd degree, these are the numbers that is not divisible by 2. Okay? So let's tagsaon na to analyze it one by one, the bullet. When we say Euler path, these refers to a path that uses every edge of a graph exactly once. Meaning to say, if meaning to say you cannot go over, or you cannot return to the path that you were able to pass through already. So that is an Euler path. Muagi ra ka sa path, sa edge, kausara gyud siya. Remember that it will start and ends at different vertices. So if you start with vertex A, you will end not in the vertex A, at different vertices. When can we say that a graph has an Euler path? So this is the idea that you have to remember. A graph is an Euler path if it has exactly 0 or 2 vertices of odd degree. Okay, if it is more than that, or it means to say if there are 3 or more vertices of odd degree, meaning to say the graph does not have an Euler path. In connection to that, when we say odd degree, by the way, it's a vertex connected by an odd number of edges. Okay. It is also important to define what is an Euler circuit. Euler circuit is it starts and ends at the same vertex. Okay. A circuit that uses every edge exactly once. Okay. Similar concept to the Euler path. It will always use the edge exactly once. Okay. Dili pwede mo balik-balik sa edge. It will start and ends at the same vertex. Sa path kaganina, the vertex, the starting point would not be the end point. But in an Euler circuit, if you start at A, you will end at A, but your goal is to travel all the edges exactly once. And it exists only if every vertex has an even degree and the graph is connected. Remember, there is no Euler path in Euler circuit if the graph is disconnected. Meaning to say, if it is not close na siya kanang agianan, so that is a disconnected graph, and an Euler circuit does not exist. During the discussion or the previous discussion about Euler path, as I mentioned earlier, you can still consider a graph, you can still find a path, an Euler path of the graph, even if there are two vertex that are odd degree. However, in an Euler circuit, in its definition, you cannot allow one vertex, any kanang kuan, bisag one vertex that has an odd degree. All vertices should be an even, should have an even degree. Okay. Now, let's have an exercise. So, which of the graphs below have an Euler path? Which have an Euler circuit? So, I'll be showing you 6 graphs here, and let us all identify which has an Euler path. Euler path muna. Okay? So, you can pause the video and try to answer it yourself. So, the graphs are labeled as G1, G2, G3, G4, G5, and G6. Remember the definition of an Euler path, or one of its important characteristic. You can find a path of a given graph if there are 0 or 2 vertices that are odd degree. Okay? So let's try to count the degree of every vertex of the graph. By the way, G1 is considered or is disqualified already because as you can see here, the first graph is not a connected graph. Na siya'y buslot dere. So there are vertices that are not connected. And obviously, its degree is 1. It's 1 is an odd number. It's more than 2 already. So it cannot have an Euler path, of course, an Euler circuit as well. How about this one? Let's try to identify the degree of this vertex. The degree is 1, 2, 3. The degree here is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 1, 2, 1, 2, 3, 4, 5. Okay, very good. So since there are two vertex that are odd numbers, so it has an Euler path, but walang circuit. So only a path. You can find an Euler path, but you cannot find an Euler circuit. So balikon na ko, pag path gani, it is not necessarily to end the vertex where you started. But if it is a circuit, if you start at A, you have to end up with A. And since there are 2 vertices that are odd degree, that are having a degree, so you cannot have an Euler circuit to graph number 2, only a path. How about this one? This is 2, this is 2, 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 1, 2, and 1, 2. All vertices are even, therefore it has a path and it has a circuit as well. Okay, and here we get 2, 1, 2, 3, 4. Okay, 4 as well. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. So there are 2 vertices that are in a degree, meaning to say it has an Euler path, and so on. So for graph number 5, 2, 4, 4, 2, 4, 4, and 4. All vertices are even. Therefore, it has an Euler path and it has an Euler circuit as well. How about this one? 1, 2, 3. 1, 2, 3. Oh, already. So you can actually 1, 2, 3. I think all the vertices are odd. Mean to say it has no Euler path and of course no Euler circuit as well. So in identifying whether a given graph has an Euler path or Euler circuit, if a given graph has at least 0 or 2, I mean, it has only 0 or 2 vertices that are odd degree, in odd degree, that means it has an Euler path. You can say that it is an Euler circuit if all the vertices are even. That's it for our first exercise. Moving on, let's continue. Okay, let us continue. Okay, let's try to find an Euler path in a given degree. Of course, let's check first if there is really an Euler path. Can we identify the number of vertices? Oh, let's try. Okay, B has 1, 2, 3, 4, 5. A has 2 degree. C has 1, 2, 3. D has 1, 2, 3, 4. And then this is is 1, 2. So as you can see, there are two vertices that are odd, and these are the vertex B and C. And since it's satisfied to the condition of an Euler path, meaning to say the given graph has an Euler path. So our task now is to find an Euler path. Okay? You can pause the video and you try to answer it on your own. Okay. An Euler path is found using this one or using this path right here. So an Euler path is written in this manner. BBA, DCD, EBC. How are we going to trace that? So one of the Euler path that we can find is, as you can see, it's a loophole. So you start with B, B, tapos travel ka ni A, tapos ni D, tapos ni C, tapos ni D, ni E, ni B, and ni C. Okay, para di maglibog, we can actually trace it right here. So you start with B, tapos you go with A, tapos you go with D, you go with C, here. Okay. Your goal is to travel all the edges once. So, na-travel ang kanang edges. Pwede raw balik-balik sa vertex but the edge. That is an Euler path, and that's how you will write path or an Euler path. Then ano right, tapad ra ang mga vertices. Okay, let's continue. Next is find an Euler circuit. So let's go back to the definition of an Euler circuit. Again, you can only say that it has an Euler circuit if all the edges are in even degree. Okay, let's try to see. A has a degree of 2. B has a degree of 2 as well. Now, A has a degree of 2, B has a degree of 2 as well, C has a degree of 2, D has a degree of 2, 1, 2, 3, 4, E has 4, and F has 4. I mean to say it is possible for us to get an Euler circuit. So let's try to trace an Euler circuit. Paano kaya? Okay. So you can pause the video and you'll try to solve it on your own. I'm sorry about that. Okay, so you can have A. Let's try lang. Sure. This one. This one. How about this? Think dapat ang start like here. Let's just try it. Ooh. However, I know that. Alam ko na. Okay. You start at A. You start with A to B, to F, tapos to E, tapos to F again, and to D, C, and E, A. If we are going to write it, A, B, F, umana to sa F, we go to E, tapos we go to F again, we go to D, we go to C, we go to E, and you go to A. So this one. Let's try to see if our answer is correct. Okay. Okay. That's another way. Pwede po siya. But this is still correct, class. Okay. By the way, it has many or there are many possible Euler circuits where you can find it. Let's try to see their answers. So our answer is still correct because we're able to travel all the edges once and we go back to our starting point. But for this example or for our given, we got or we start at A. Clear all drawings muna. You start with A. Take a look at this one, but let's have a different color. Let's make use of a different color. Pero nag-end ba siya? Okay. This one will have a green color. Okay. It starts with E here. We travel to A. Tapos ni B, ni F. Tapos ni E. Tapos ni E, ni F, balik. Tapos D, C, E. Okay, that's another Euler circuit. Okay, remember that in a given graph, you can find many Euler circuit as long as it satisfies its definition about Euler circuit and Euler path. Okay, so before we will move on to our next topic, let's go and have some recap. Euler path, you travel the edges exactly once, but you start and ends with different vertices. You can only say that it has an Euler path if and only if there are 0 or 2 vertices that are having an odd degree. When we say Euler circuit, it is a path where you can travel all the edges exactly once, okay? Exactly once, but you will start and end at different vertices. Say, for example, gisuko ka sa imuhang mama. So, dapat moagi ka aning dalana, pero kausara ka, di ka pwede magbalik-balik and you have to go back home. So, that's an example of tracing an Euler circuit. Okay, so you travel the edges once only. You cannot go back to the edge twice, but you start and ends at the same vertices. Okay, so we are done with the first half of our topic for this for today. That is an Euler circuit. Let's move on to a different topic or to the continuation of a topic. But of course, para dili gid ta kalimot, let's have this kuan. Summarization. Remember, it uses all the edges. Check for both Euler path and Euler circuit. It starts and ends with the same vertex. X for Euler path. Check for Euler circuit. And then, of course, add degree. So if it has 0 or 2, add degree vertices. That means it has an Euler path. If it has 0, add degree. If all vertices are even, meaning to say that is an Euler circuit. Real world use, road covering, and loop coverage for the path and the circuit. Okay, let's go to our another topic. This is about Hamiltonian. Okay, there are 2 concepts as well that it is important to remember: the Hamiltonian path and Hamiltonian circuit. When we say Hamiltonian path, a Hamiltonian path is a path that visits every vertex exactly once. It may or may not return to the starting point. Parehagya po siya sa Euler circuit, but its only difference is that kaganina sa Euler, your goal is to travel the edges exactly once. But today, your goal, or I mean in Hamiltonian path, your goal is to travel, I mean to visit the vertex exactly once. Pwede ka magbalik-balik sa edge, but sa vertex is dapat mo visit ra kag kausa. It is a Hamiltonian path if you did not or you will not return to your starting point, just like the example here. So you start with this button, I mean with this vertex, you travel and then you end a different vertex. But the goal is to travel along the edge. I mean to visit the edge, to visit the vertex exactly once. Okay? And it focuses on visiting all locations, not necessarily all routes. If the focus is to visit the location, that's Hamiltonian. If the focus is to visit or to travel the edge exactly once, that is Euler. Okay. And of course, when we say Hamiltonian circuit, it is a path that forms a cycle. It starts and ends at the same vertex. It visits every vertex exactly once, pero kung sa path, dili ka necessarily mobalik sa imong starting point sa circuit is you have to go back to your starting point. Just like this example. Okay? Yeah, balik ra ka. Okay. That's it. So Hamiltonian path. Let's try this activity. Find the Hamiltonian path that starts A and ends in E. Okay, mag-start siya sa A, mo-end siya ni E. Let's try. You can actually have many Hamiltonian paths. You can pause the video and try it yourself. But let's try. A to C, and then to D, to G, to B, to E. Oh, di siya pwede. Kaya balik na ka. Wrong na siya. Okay? Kaya balik man ka sa E. Dapat mo visit raman ka pausa. Let's try a different path. What about if we will go over with this one? Ganito. A to B, G, D, oh, wow, we got it. Okay, kita na nato. But where is it? Here, okay. Yan. Again, balik A, B, G, D, F, C, E. A, B, G, D, F, C, E. So it satisfies that it starts with A and ends with B. So that's the condition. But you cannot, if there's no condition, nga, asa ka mag-start, you can actually find many Hamiltonian path in the given graph. Okay? A, B, G, D, F, C. How about the second? For this example, you are asked to find the Hamiltonian circuit. Remember that in Hamiltonian circuit, you have to visit all the vertex once. However, visit ka sa vertex once. However, dili ka pwedeng mo start ka kung mo-end ka kung diin ka nag-start. So for this given example, Hamiltonian circuit, we will start at A. You try to trace it. So you start at A, B, G, D, F, C, E, A. Balik na. I-continue na nato kagani. Ayan, balik na similar to that. You can also try this path. Okay? Pwede sad siya nga path. Let's use a different color. This one. Na. Pwede sad siya kaning path. B, G, B, F, C, E, A, B. Okay, kada siya. Basta naka-visit siya sa tanan. That is a Hamiltonian circuit. Okay? If you do have questions, you can type it in, drop it on the comment section if you have questions so that we can interact as well. Okay, now let's go to a real life example of the concept Hamiltonian circuit. Okay, so here's the situation. After the 6.9 magnitude earthquake that struck in northern Cebu, emergency teams in Bugus City needed to visit all evacuation and relief sites once to deliver supplies efficiently. This is a very good application of the concept of Hamiltonian circuit because it will cost a lot of time and effort and money if you will visit kanang more than once to a specific evacuation sites. Kanang balik-balik na ka. So it's important to identify the route wherein you can visit all the evacuation once only. So these are the sites. It will start with the City Hall, and San Vicente is labeled as B, Gairan is C, Pulambato is T, Odlot is E, Don Pedro is F, Dakit is G. These letter B to G here, these are the evacuation sites. So our goal is to plan a route that allows the rescue team to visit every site once and return to the command center, which is the City Hall, similar to finding a Hamiltonian circuit. Our goal is to find the path where we can visit all the evacuation center once, but we have to go back where to the City Hall. Okay. So of course, in crafting or in illustrating the problem, so you start with a label first and you try to position the roads, the different roads. Okay. So this is now the Bugu City post-earthquake supply roads. Asa kita mag-start sa center, sa City Hall. So if we can have that, we will try to find a way asa siyang Susunod, for the illustration, luckily for our illustration, kay kuan siya no, daghan siya og connection yan na siya sa Center City Hall. So we will not find it difficult, or it will be easier for us to find different roads. Okay, you start at A, you travel at E. This is one lang ha. E, A, C, B, E, A, C, B, tapos D, F, G, D, F, G, and of course, balik ka sa A. We're able to travel all of it. 1, 2, 3, 4, 5, 6, 7, 8. Sakto ba? 1, 2, 3, 4, 5, 6, 7. Sakto, 8 man kayo mo balik ka. So this is just one road. Mo travel ka from City Hall adto ka ni Udlot, dayon ni Gairan, ni San Vicente, Colambato. Sorry, F class is not a City Hall ha. I overlooked on this one. Ang sa gini nga place ang F. Itong tanawan. Isa na siya nga place. City Hall is labeled as A. Okay? So, ang F is saan na siya nga puan? What happened? Okay. Letter F is Don Pedro. Don Pedro na si Balikon sa... Okay. Letter F is Don Pedro. Okay? Remember, class, that I only give one passable route. You start at A, you start at City Hall, then you go back to City Hall. This is one example of Hamiltonian circuit. Now, your task is to find another circuit, same, you can find with this map, but mag-start gyapon ka sa City Hall, yung end ka sa City Hall. So you try to find another circuit, then you drop it in the comment section. I'll be reading and giving an additional points for those who will drop or try to find an answer. Try to find or share their answer in the comment section. Okay? And that's it for our session. You can drop your questions as well in the comment section para ma-entertain na to and we can interact with each other. Okay? That's it. Real life application. For the sorry. For an Euler circuit, kanang mo travel ka sa kanang road ka usa, that's postal delivery, para di ka magbalik-balik, di ka magka sa gasolina. Street sweeping and garbage collection, of course, para dili magkas gihapon sa time. Utility inspection bus. Hamiltonian circuit, mo visit ra ka sa place ka usa, traveling salesman problem. Kanang, kuan ba, dili ka mo balik-balik sa balay. Tour planning, dili balik-balik sa imong destination, and route optimization in logistics, kanang mga Shopee, Lazada, and many others. That's it for today. Thank you for listening and watching the video and for your kanang kuan, your positive interactions. You can drop your um comments and some examples or the examples, an example of Hamiltonian circuit in the comment section. Thank you, everyone. Goodbye. Have a blessed day and stay safe. Bye.